We want to find the accumulated amount after 4 years. So T is equal to 4. If $5,000 is invested, so we know that that's what the initial amount invested at 8%, compounded continuously. Compounded continuously. That's another one of those. If you see the simple interest written, use the simple interest formula. If you see compounded continuously, you have to use the compounded continuous. So that is just A equals PE to the RT. Students like to call this the PERT formula, the shampoo formula. Obviously, the PE to the RT, this is a shampoo formula. But okay, so A is equal to P, which is 5,000. Then we'll do E, the rate. I'm going to put this in parentheses because I've got to multiply two things up here. So 0.08 times 4. Okay, so together, how we're going to put this in the calculator is you're going to type 5,000, then hit second ln. It opens up everything for you, including the parentheses, and all you have to do is type 0.08 times 4, close that parentheses, and then what comes out looks like $6,885.64. And there you go. All right, let's go to example 9. How long? How long? Looks like we're finding our T value. We don't know how long. Is it going to take $2,000 to double? So our initial amount is $2,000. We want to double it, so then what's coming out is $4,000. If the investment earns interest at a rate of 9% per year, compounded monthly, just like that. Okay? So my formula, A equals P times 1 plus R over M to the MT. Amount coming out is 4,000. The amount going in is 2,000. 1 plus 0.09 divided by 12. All of that to the 12t. Okay, so let's divide off 2,000. So that way we can just, our whole goal is to get this variable way up in there. So the first thing first, let's get off the stuff in the front. And 4,000 over 2,000 obviously is 2, which is good because that represents the fact that we're doubling. If it was 3, we'd be tripling our money. And then it's equal to 1 plus the 0.09 divided by 12 to the 12t. Okay, let's go ahead and get this base. Let's clean that up. So 2 is going to equal, and if you just do that 1 plus 0.09 over 12 in your calculator, you're going to get 1.0075 to the 12t. Okay, so now what I'm about to show you next is the most important thing for this whole entire example right here. And what we're going to be doing is referring back to properties and logs. So it's going back to the chapter right before this, chapter 3. Anytime you want to solve and your variable's up in the exponent, do this, okay? I'm going to start out, you know how you can always just square each side, or you can take the square root of each side? What I'm going to do is take the log of each side. So anytime you want to solve for a variable up in the exponent, just take the log of each side. So I'm going to write it as now, the log of 2 is equal to the log of 1.0075 to the 12t. And this is totally legal. I can definitely do this. Just like you can square both sides of an equation, you can take the log of both sides. All right, now we have that property that says if I have a log, here's my what I'm taking the log of. If it has an exponent, remember what I can do with that? I can move it down front. That's what I'm going to want to do. Okay, so let me get some room for just a second. Let me erase some of this. I'm going to come back up over here on the left. But, okay, coming back up over on the left then, I have log of 2 is equal to, let's drop that down front, so 12t times the log of the 1.0075. Well, look here, I've got 12 times t times the log. I've got basically 3 things multiplied together, so let's just divide off the part we don't need, which is the 12 times the log of 1.0075. And the same thing over here, so 12 log of 1.0075. So the 12s go away, the log of 1. And we just get the t. Okay, so plugging this in our calculator, what I would probably do is I would hit log of 2, close that parentheses, and then divided by, open up another parentheses, and go 12 log of 1.0075, and close parentheses, and hit enter. And I get t to be 7.73, and there's your answer. So roughly 7.73 years, so 7 years and 3/4 of a year basically. It's a little over, not quite 8 years, but it's going to take for you to, in order for your money to go from $2,000 to $4,000, or in order for it to double. Okay? Now let's just pretend we kind of want to get a little technical here though, just to say if we want to get technical. 7.73 years. Okay, what you want to do, if you want to convert this to months, is you want to take that 0.73 and you want to multiply it by 12. Okay? Okay. So that's going to be 7 years, the 7 coming from that part, and then the 0.73 times 12 is going to represent the number of months it takes. And it comes out to be about 8.7. So I'm going to round up. I'm going to say 9. Because for sure, if you round down to 8, you haven't really doubled your money. If you round up to 9, you for sure hit the double amount. So really, 7.73 years is 7 years and 9 months. So that's the way to do it if you want to just take that decimal and multiply by 12. The whole number is the number of years, and the decimal represents how many months. Okay? And again, that's just to get technical, but I wanted to show you guys that just in case. If you were wondering, it is. Okay, let's find the interest rate. The interest rate that's needed for an investment of $5,000 to grow to $6,000 in 3 years if interest is compounded continuously. Okay, since we're compounding continuously, we get to use the shampoo formula, the PERT formula. We want $5,000, our initial investment, to grow up to $6,000. We have a total of 3 years for this to happen. And we want to find R. So R is our question mark. Going into our formula then, 6,000 is equal to 5,000 E to the R times 3. Okay, let's divide off that front coefficient just like we did before. And I'm not going to write it as a decimal, I just want to write it as 6/5. Okay, so 6/5 is equal to E to the, I'll say 3R. Okay, and just like we did in the example before this, that's where my variable's sitting. It's sitting up there in the exponent. So what I'm going to do is where we want to either take the log so that we can move it down front, but in this case specifically, since my base is E, what I'm going to do is choose to do the natural log instead. Because remember, the natural log is a log that has a base of E. So I'm going to write this as the natural log of E to the 3R. Again, only choose natural log whenever this number right there is an E. Okay? So the natural log of 6/5 is equal to 3R times the natural log of E. Well, the natural log of E is just 1. And if you want to, just double check in your calculator, because remember that base matches with that base, and you just get that exponent sitting right there, which is 1. Okay, so I have the natural log of 6/5 is equal to 3R. Just divide both sides by 3. And so if you wrote it all out, you get R to be the natural log of 6/5 over 3, or using your calculator, you should get an R value of, let's see, 0.0607, or if you round that last number, we can say 8. Okay, let's convert this. So basically 6.08% is the rate that's required for compounding continuously and for 5,000 to grow to 6,000 in 3 years. All right, example 11. This example requires us to use obviously the book, number 40 in the book, on page 198. So if you guys can do me a favor, just pause the video, crack open your book, go to page 198. Let's just look at number 40 for 2 seconds. Get your thoughts around it, get an idea of how that problem is going to work. If you want to go ahead and work it yourself right now, go for it, and then let's just come back and check with some information that I have. Okay, so just reading through the problem initially, it talks about that Jennifer was awarded $150,000 5 years ago at 12% per year, simple interest. So if they were going to give the equivalent of that award today, how much would they have to cut the check to her? Okay. Obviously, we're using the simple interest formula. So we want to use that A is equal to P plus 1 plus RT. Okay, simple interest formula. Now, she was awarded $150,000 5 years ago. So that's what's going to be our principal amount. That's what was kind of like, consider this almost like you let somebody borrow that much money, 5 years ago. The rate is 0.12 and the length is 5 years. Okay, so what we're going to do is when the A comes, with this money that comes out, this A, that's its equivalent. Almost consider it like inflation rate or something. In other words, $150,000 5 years ago, what would be its equivalent today? And that's what this A value is going to tell us. Okay, so when we plug this in our calculator, what's going to come out is an amount that is equal to $240,000. Okay, so basically that a company would have to pay Jennifer $240,000 if it was happening today as opposed to 5 years ago. And there's the answer for that one. Okay, as we look at example 12, what I want to point out is instead of doing number 48, let's look at number 47 actually in the book. Still same page, 198. So why don't y'all pause it for a second and we'll come right back to this point. Okay, so just kind of looking in general, wrote down some information. And the reason why I want to look at 47, I think it's more beneficial to look at this one than it really is to do number 48. But you're looking to buy a house in 4 years. Right now it's worth $210,000, but we know the cost of increase is going to go up 5% per year. So how much is this $210,000 home going to cost 4 years from now if we're going to go up by that rate? Okay, so the easiest way I can look at it is let's do a table of values, where we're going to have year in one column and value in the other. So at the very, very start, when you're basically at year 0, the price of the house is going to be $210,000. Okay, but within that first year, to go from year 0 to year 1, we need to add 5% in value. So you need to take the $210,000 and we need to add on 5% of that $210,000. Okay, so that's going to equal, looks like $220,000 and $500. Okay, so we need to do the next thing for the next interval. So why don't y'all do this? Let's do this together. Once y'all define some of these values, that's going from year 0 to year 1, then 1 to 2 to 3 to 4, however many we need to do this, okay? Once y'all to fill this out, and let's come back and check our numbers. Okay, so I just kind of quickly filled the numbers in, but let's analyze what the question says. We want to buy the house in 4 years. Okay, so right now, it's worth $210,000. After 1 year, it's $220,000. 2 years, $231,000. 3 years, $243,000, and then right there, 4 years. That's the answer to the question. So in 4 years, that same house is going to be worth $255,256. So roughly, the difference between the two over 4 years, it looks like you're going to have to pay an extra $45,000 more. Okay, let's go on to the next example.